Hello and welcome back to the debugging point. In this video, we are going to talk about character pointers. So you might have already noticed by now that all the examples that we have taken are only and only for integer pointers. None of them is for character pointers. Now we'll be looking at how the character pointers work and how the character pointers and character arrays work differently than that of the integer pointers and integer arrays. All right, but before actually discussing about character pointers, I want to discuss about character arrays. See, basically there are two methods of defining a character array. The first method is These are the two methods. The first method is char c1, then you have your square brackets equals to different character elements. Alright, this is the very standard way, and we define our integers also in the very same way. However, there is another special method for specially for characters, which is the second method, which has been demonstrated in this example. Char c2 square brackets is equal to double quotes ABC. Now essentially the first method and the second method is absolutely the same. There is a difference in terms of declaration. See, the above character also has three elements, the below character also has three elements, that is A, B and C. The only difference is in the type of initialization, the method of initialization. All right, so both of these are the methods to define a character array in case of C++. All right, so let me first demonstrate it to you with the help of the code. So see, this is the code. We have two characters two character arrays C1 and C2. So let's just try to output them directly, and let's see what is the result. So see what exactly is happening in this case. When we output C1, what happens is that the functionality, or I should say the method in which the cout has been written for character arrays, is very different. When we had an integer array, let's say we have an integer array int a, and this is simply an integer array of, let's say, size 10. All right, and we see out the integer array and we see out a. So what exactly happens in this case is that when we try and run our code, so for the first case the address is printed. If we see out a, for the case of integers, simply the address is printed. That is, we know that a behaves like a pointer to the array, and it has the address of the 0th indexed element of the array. All right, it behaves very similar to that. But for the case of characters, the character array c1 and character array c2, when we see out them, what exactly happens is, instead of printing the address, or I should say the starting address, they rather print the elements present inside the array. So for the above case, we see C1 elements A, B, C are printed. Let me zoom it for you so that you can see it very easily. Alright, A, B, C is printed, and after that some garbage value is printed, which will see why is it being printed. And for the second case also, ABC is being printed, but after that no garbage value is being printed. Alright, I hope this difference is clear to you. Now coming on to the second point, for the case of C1, some garbage value is also being printed after the elements of the array, while this is not the case in the second one. So what is the reason for that? The reason for that is that when you define an array, a character array in this format, what the C++ compiler does is that it takes the elements A, B, C, and after taking all these elements, it also adds an element at the end, which is the null character. It also adds the null character to the end. Of course, we cannot see this. This has not been given by us. This the compiler adds by itself when we define a character array in this format. However, if we define a character array in this format, then the compiler does not insert this null character at the end of the array. So essentially how the cout is implemented in C++ is that it is instructed to print all the elements from the starting point until it reaches backslash 0, until it reaches backslash 0. All right. So what was happening in the first case? We we the compiler printed A, then it printed B, then it printed C. But since the in this format the compiler does not add a backslash 0 at the end, so whatever it was kept next in the memory, it started printing that very thing. All right, it started printing that very thing, but it keeps on printing until it reaches backslash 0. So A was printed, then B, then C. After that, these three characters, garbage characters, were also printed, and after that it must have, you know it must have hit a backslash 0. That is why it stopped. Similarly, in the second case, since we have defined the character using double quotes, so by default a backslash 0 would be inserted by the or would be present at the end, alright, which would have been inserted by the compiler. So when we see out C2, it actually prints from the starting until it reaches backslash 0. Alright, it stops as soon as it hits backslash 0. I hope it is clear to you. Now we can also see or check the size of C1 and the size of C2. Alright, so let's try and print this. You see, the size of C1 comes out to be 3, whereas the size of C2 comes out to be 4. Why? This is essentially because the first in the first method, the C1, when we initialize our character this way, then only 3 elements are present. There is no fourth element which has been inserted by the compiler. But in the second case, by default, the compiler inserts one more extra character, which is the null character, when we initialize our array using double quotes. So its size comes out to be 4 in the second case, whereas it just comes out to be 3 in the first case. I hope the concept is a little bit more clear to you. So these are the two different ways of initializing character arrays in case of C or C++. Alright, and the difference between them as well. I hope this is clear to you now. So moving on, now let's see the difference between a character array and integer array. Alright, so see, we have already seen this, that integer array is defined in this way, whereas character array can be defined in two different ways. And these are the two different ways. These we have already discussed earlier. I hope this is clear to you. So moving on, see, we already do know that if we have an array of integers, let me draw it for you. Let's say if you have an array of integers, and let's say you have a pointer pointing towards the zeroth indexed element of that integer array. All right, let's say the first element is 1 and this is the pointer, let's say p. All right, and this is an integer array. So on doing p, we actually, on doing cout p, we actually get the address of zeroth element of the array. All right, this is the address of zeroth element of the array. Whereas if we have a character array and we have a pointer pointing towards the zeroth element of the character array, if we do cout ptr, then the entire array gets printed, or I should say it starts printing character from that very address until it reaches \0. So what do we say? What is the output? A, then B, and then C. This is actually the output. Let me repeat it once again for you. See, PTR has the address of, see here, see the code. PTR has the address of zeroth element of the character array C. Alright. So if PTR has the address, if we do cout PTR, then if it was an integer array, then it would simply print the address. But if it is a character array, then it would start printing characters from that address onwards until it reaches \0. So it will print A, then it will print B, then it will print C. As soon as it hits \0, it will stop printing. Alright. What if we had star PTR? Then star PTR behaves the same way as that it would behave in integer array. It would just simply print A. Star PTR means it would just print that character, that very element which is present, towards which it is pointing. All right, we can also verify this if I am telling truth or not. So you see, we have two character array which we have discussed earlier. We have tried cout c1 and cout c2. If we have an integer array and we do cout a, then what exactly happens is that it actually prints the address. Let me show it to you with the help of example. See, in the first case on line number 8, we have some ABC, then some garbage value printing, and after that it would have encountered \0, so it stopped. In case of 8, line number 9, since cout is defined using double quote, so it would have \0 at the end inserted by the compiler, therefore it would simply print ABC and nothing else. Since A is an integer, so on line number 12, it would simply print the address, the starting address of the array, the zeroth element index, the zeroth element address of the array. Alright. Now after that comes line number 15. So we have a pointer PTR which is pointing towards the zeroth indexed element. Alright. So if we do PTR, then it would start printing characters from there onwards until it reaches \0. Since we know that here we have a \0 at the end of this, therefore it prints A, then B, then C, then it would have encountered C. It would have, this line would have encountered \0, so it stopped. However, on doing star PTR, it just simply prints that very character. Alright. Now things get a little more weird when we have a character X, we have a pointer pointing towards it. If we do see out X, simply that X character would be printed, but if we do see out X1, then what exactly happens is that it starts printing those characters until it reaches backslash 0. So it first prints X, then it moves on to the next memory location, which is 1 byte ahead since it's a character. So then it would print whatever is present, whatever character was written in that 1 byte. So it printed that one character. Then it moved to the next character, the next memory location. It would have encountered backslash 0 there, so it stopped. Alright, we already know that. We already know the drill. Alright, so here, let me elaborate it to you. See, in this case, we have x1 which is the pointer and x which is the character. So this is the character and this is the pointer. So if we do see out PTR, what exactly happens? It starts printing character from this location. Alright, so first it prints x, then it prints the next character, 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 then it prints the next character until it reaches backslash 0. So as soon as it reaches backslash 0, it stops. Alright, so now I want to, so these are the some of the important information which I wanted to give you. One small thing, one small word of caution which I would like to give you is that through this question, see, what what do you think? What is the difference between this and this piece of code? What is the difference between line number 26 and line number 27? See, let me elaborate it and tell it to you. What essentially happens is that when you initialize something, see, when you initialize something, you give some value to a variable or an array or anything. What exactly happens? Let's say I am talking about this very line, the first line. All right. So the value which we are trying to assign to a particular variable or array is first stored in some temporary buffer. Alright, it is first stored in some temporary buffer. After that, the compiler allocates some memory for that variable, and then the value is copied from the temporary buffer into that memory. Alright, so when you execute the above piece of code, what happens is that a temporary buffer is created in which a b c d e backslash 0 is saved. After that, it copies, a memory is allocated for str by the compiler, and then this value gets copied from the temporary buffer into that allocated memory. Alright, whereas in the second line of code, what exactly happens is a pointer is defined, some 8 bytes of memory is allocated to that pointer, and I'm sorry, some 8 bytes of memory is allocated to the pointer, and in that 8 bytes of memory, the address of this temporary buffer gets stored. Alright, so let's say the address was some 11x. Alright, 11x is the address of the temporary buffer. So this temporary buffer, the address of this temporary buffer gets stored in the pointer. Actually, this line is not advisable. We are never advised to execute such kinds of. We are actually never advised to perform such an action. This is mainly because this is a temporary buffer. Alright, a value cannot be retained in this memory for a very long period of time. Alright, The compiler uses temporary buffers for many other processes, so this value is overwritten very frequently. Alright, so pointing to this variable, to this temporary buffer memory, can be very dangerous. Alright, so I hope this session was clear to you. If you are liking my content, then please do like, share, and subscribe. And remember that this is not an advisable method. Alright, so never do this. This can be very wrong, and this is rather the correct thing. Alright, thank you.